This is class 11th, chapter 2, atomic structure. And here in this lecture number 6, we shall discuss about the Bohr's atomic model. You have learned about the emission and absorption spectrum. Here suppose we take a sample of atomic hydrogen. This is what? Atomic hydrogen. It's not molecular. Remember that. It's atomic hydrogen. And we know it well that the gaseous atomic state is the simplest form of matter. All these are surrounded by one electron and one proton in the nucleus. If we pass electromagnetic waves of all frequencies of wavelengths, then what we observe when these frequencies pass through this sample and the coming out radiations, we find that certain frequencies are missing. See, this frequency passes through, this frequency passes through, but we find this frequency is missing. Means here we see a black line after getting that. Or refracting through. Suppose these pass through, right? When we split these, here we find certain frequencies missing. See, here is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Means all frequencies are here. But certain frequencies out of these are found missing. See, this is frequency number 3 which is missing. Here is 1. Though that was continuous here, here these are also continuous, except what we observe, that a certain frequency is found missing. Means what? These frequencies were absorbed by this sample, and every time the same frequencies are absorbed if this element is the same. If we change the element, different frequencies are found missing. Means the different frequencies are absorbed, and these are a number of frequencies which are found missing. First of all, the frequencies in the visible region could be observed by Balmer. Balmer studied this absorption or emission spectrum of the hydrogen atom in the visible region, and he could find a mathematical relation among these frequencies or the wave numbers. Wave number is denoted by nu bar. Nu bar. And what was the relation? Relation was that nu bar is equal to 1096777 into 1 upon 2 square minus 1 upon n square per centimeter, where n is a whole number starting from 3, like 3, 4, 5 and so on. That was the relation in this. And this series is called Balmer series. Niels Bohr applied Planck's quantum law. You know that Planck could describe black body radiations by postulating that energy is quantized. So, applying the same law, Bohr postulated that in hydrogen, the electron also can absorb or emit certain radiations only, and the corresponding packet of energy is absorbed or emitted by the electron. That is why, suppose here this is the electron. If it absorbs energy, it can absorb a certain minimum amount of energy to go up, and it cannot absorb any other amount of energy intermediate between this, means that photon won't be absorbed. And during transition from this to this, going from this orbit to this orbit, the net difference of this energy is emitted in the form of a single photon of that frequency, because according to the Planck's law, the energy or the photon of a certain frequency that has this much energy. That is why if this amount of energy change is there between this and this orbit, then this frequency shall be emitted by the electron. Let us discuss Bohr's postulate in detail. Bohr proposed that in an atom in the ground state, means this is the closest orbit in which the electron revolves generally, and when energy is supplied to this electron, it would absorb only a certain amount of energy and not any amount of energy. And if that amount of energy is supplied to this, corresponding to that, it would go to the higher level and it would absorb this amount of energy in a single quanta, means h nu. If the difference in energy in these two orbits is equal to this, only then that shall be absorbed by the electron, and immediately it would come from this state to the ground state. Ground state means this is orbit number 1, means n is 1. And similarly, if another frequency is available which this electron can absorb, then it would go to another orbit. and the corresponding amount of energy would be absorbed. Means a certain frequency shall be absorbed, and the same frequency would be emitted if it goes back to this ground state. Then how much this energy would be absorbed? It was the genius of Niels Bohr who proposed the law. He postulated that the electron here would have angular momentum which would be whole number multiple of a quantity as h upon 2 pi, means its angular momentum, that is m v r is whatever the radius is. Suppose this is, so this is r1, this is r2, and so on. Electron would go only in the orbit, only in that orbit in which its angular momentum is whole number multiple of h upon 2 pi, where h is the Planck's constant. Means when n is 1, then corresponding r1 would be its path, and if it is 2, then it would go, electron would go to that orbit where its angular momentum is 2 into h upon 2 pi. Similarly, it would go to the third orbit where its angular momentum is 3h upon 2 pi, and not in between there. I think this is now clear to you. Means electron would remain in the shortest orbit where its angular momentum is equal to h upon 2 pi. Then it will go to the next where its angular momentum is 2 into h upon 2 pi, and it would, on absorbing energy, would only exist in specified orbits. Let us go ahead with some simple calculations, that how this R1 can be calculated and how the energy E1, E2, E3 can be calculated, and how the energy difference between, see, this is E2, this is E1, then this difference of energy would be equal to h nu. We know the amount of energy. We shall calculate by Bohr's equation. We are just going to derive that. E1 would be equal to h nu. H is the constant, Planck's constant. If we know the energy, we can come to know about the frequency emitted. Means nu, frequency emitted, would be equal to energy difference between E1 and E2, means E1 minus E2 upon H. That would be the frequency emitted. E1, E2, when transition is from this to this, then this frequency shall be emitted. If between this and this, then here it would be E3, and so on. Let us go ahead with the calculations. Now let us calculate that how Bohr could give an equation to find out this R, any R. See, this is R1, this is R2, and so on. His equation could calculate R1 also, means the radius of any allowed orbit, be that R1, R2 or any. We can say that Rn. He could give that. He could give the equation for that, and also he could give the equation in which we could calculate the energy of N1, or we can say energy of first orbit and energy of second orbit and energy of third orbit. From that we can also calculate the velocity of electron in first orbit or second orbit or third orbit. How? Let us go ahead. First, we derive the equation for the radius. I told you that main postulate of Bohr was that the angular momentum means mvr, or we can say mass of electron, velocity in nth orbit and radius of nth orbit in any orbit is whole number multiple of h upon 2 pi. It was the genius of Bohr that he could find this relation between the momentum of the electron and the Planck's constant. From this, by knowing this relation, we can find out energy of any orbit, R of any orbit, and also velocity of the electron in any orbit. How? Let us go ahead. We know that the electron should go round in an orbit where we know that the electron would go round in an orbit where the Coulombic attraction between positively charged nucleus, this is positively charged, this is negatively charged, Coulombic force of attraction is there, means this force, Coulombic attraction, must be equal to the centrifugal force. This is centrifugal force and this is Coulombic attraction. If both are equal, then it would keep on revolving in this. Means what? We know that the Coulombic attraction, the force, the Coulombic force can be calculated by this equation. Where this 1 upon 4 pi epsilon 0 is the permittivity constant for space. So permittivity constant multiplied by Q1 Q2 upon R square. This is the equation. Here Q1 is what? The charge on the nucleus. Q2 is what? Q2 is charge on the electron. We know that the quantity of charge on an electron and a proton, that is equal just in opposite in sign, means positive and negative, but quantity is equal, and that is equal to the charge of the electron. That is why we can see that it is number of protons multiplied by the number of charge on one electron, that gives the charge on the nucleus. If there are two protons, the Z would be 2 multiplied by the charge on one electron. And here, because electron is single that revolves around, that's why charge would be this much. Or we can see that a square, and this R is also should be square. That's the Coulomb's law. And what's another law? That force of this centrifugal force. This is force of attraction. And centrifugal force is given by what? That is mv square upon r. Here this force must be equal to this force, then the electron would remain in the same orbit. Means this should be equal to Is that clear? Simply we are putting values here. Here it is R square, therefore it should come out to be mv square is equal to this much. Here let us find out the value of v square from this equation. How can we find that out? We need to find its square value. Therefore, when this goes to that side, the v comes out to be 2 pi m r. And if we do the square, it should be h square. It should be 4 square. And let us put this value here. Then this equation comes out to be v square mv square. Here I am putting the value mv square, and this value is to be put. Therefore, that comes out to be m square h square upon 4 pi square m square r square. Right? This is the value for v square. So this is mv square. And this mv square should be equal to this. Means what? Let us write this equation here. I am shifting this equation on this side. Therefore it goes here 1 upon 4 pi epsilon 0 z square upon r. Copying down m h square four pi square m square r square. Here m square, then what is left? M is gone, and here m is left. We find this equation, and from both sides you see here is r square. Therefore, if you multiply both sides with r, then this r is gone and r is left. Let us now from this equation find r. What would happen? This side goes on this side. If comes that on this side, then what should happen? ZE should go down and 4 pi epsilon 0 should go up. So here I am writing 4 pi epsilon 0 and down on z square, and r is going this side. This r is what? NEN4, and we have got this equation. This equation is 4 pi epsilon 0 n square h square upon z e square 4 pi square n. This is equal to Rn. We know the value of 4 pi epsilon 0. We know the value of, if we want to calculate, see, for any n, suppose for 1, then that shall be gone. H, the Planck's constant we know, Z we know, E, charge on electron we know, for pi we know, m we know. That's why we can calculate this. If you put the value, if you calculate it for first and for hydrogen atom, the first orbit of hydrogen atom, then Z is also 1. Then this is R1, that is also symbolized as A0 or Bohr's orbit. We put all the values here, then it comes out to be 52 angstrom. That is how Bohr could find out the first orbit of hydrogen atom. That's it, this lecture. We shall continue this chapter in next lecture. Till then, goodbye.